A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headache.
If you're building anything with AI, check them out. Modal.com. You know, Herman, I was looking at my editor setup the other day, and I realized we're living through a massive architectural heist that nobody is talking about. Today's prompt from Daniel is about the Language Server Protocol, or LSP, and how it is being hijacked, in a good way, to become the universal interface for AI coding.
It is a brilliant observation. I am Herman Poppleberry, by the way. And you are right, Corn. We often talk about the models, the LLMs, the parameters, the context windows, but we rarely talk about the plumbing. And the plumbing is where the real revolution is happening right now. By the way, fun fact for everyone listening, today's episode is actually powered by Google Gemini 3 Flash. It is helping us pull these technical threads together.
I love the idea that the plumbing is the revolution. It is very blue-collar tech. But seriously, if you look at how we used to build IDEs, it was a nightmare. Every editor had to write its own support for every single language. If you wanted C# in Vim, someone had to write a Vim-specific C# parser. If you wanted it in Emacs, same thing. Then Microsoft comes along in 2016 and says, what if we just make a standard protocol?
The genius of LSP was decoupling the UI from the intelligence. Microsoft realized that the work of parsing a language, building an abstract syntax tree, and figuring out where a variable is defined is exactly the same, whether you are using Visual Studio Code, Sublime Text, or NeoVim. So, they created this JSON RPC bridge. The editor handles the pixels, and the server handles the brain work.
And now, the twist. We are seeing projects like lsp-ai and copilot-lsp-nvim that are saying, hey, this protocol isn't just for static analysis, it is a perfectly shaped hole for an AI to sit in. Instead of a server that looks at a local file to find a definition, we have a server that calls an API to generate the next 10 lines of code.
It is the ultimate abstraction layer. Think about it. LSP uses a stateless request-response model. When you type, the editor sends a notification. When you want a completion, it sends a request. This is exactly how LLM inference works. You send a prompt, you get a completion. The impedance match between the language server protocol and modern AI models is almost perfect.
So, before we get too deep into the AI side, let's actually break down what is happening under the hood of a standard LSP session, because I think people use it every day without realizing how chatty it is.
It is incredibly chatty, but efficiently so. Usually, it runs over standard input and output or a local TCP port. It uses JSON RPC 2.0. When you open a file, the editor sends a text document did open notification. It literally sends the whole content of the file to the server. From that point on, every time you press a key, the editor sends a did change notification.
Right, and it doesn't usually send the whole file again, does it? It sends the diffs.
Well, it sends incremental updates. The server maintains its own internal version of your file, so when you trigger a completion, the editor sends a text document / completion request with a line and character position. The server looks at its internal state, calculates what should come next, and sends back a list of completion items.
This is where the lsp-ai project becomes so interesting. For those who haven't seen it, lsp-ai is an open source project by Silas Marvin. Instead of writing a server for Rust or Go, he wrote a server that acts as a gateway. It implements the standard LSP endpoints, but instead of using a compiler backend, it uses a model, either local through something like llama.cpp, or remote through an API.
What makes lsp-ai a standout is that it treats the entire protocol as a series of prompts. If you ask for a completion, it doesn't just look at the current line. It can look at the whole file, or even multiple files if the server is configured that way, and pipe that into the LLM. The editor doesn't know it is talking to an AI. It thinks it is talking to a very, very smart version of a traditional language server.
That is the heist I was talking about. You don't need a special Copilot plugin for every editor anymore. If your editor supports LSP, which almost all of them do now, you just point it at lsp-ai, and suddenly your editor has AI powers. It is a complete end run around the plugin ecosystem.
And it goes beyond just completions. LSP has a feature called code actions. This is usually for things like extract method or import missing library. In lsp-ai, you can define custom code actions. You could highlight a block of messy code, hit your code action key, and select refactor this to be more idiomatic. The server sends that block to the LLM with a specific instruction, gets the result back, and tells the editor to replace the text.
I was playing with the configuration for lsp-ai, and the flexibility is wild. You can set up different models for different tasks. You might use a fast, small model for basic line completions to keep the latency low, but then trigger a much larger, more expensive model for complex refactoring or generating documentation via the hover provider.
The hover provider is a great example of repurposed infrastructure. In a normal LSP, you hover over a function and it shows you the docstring. In an AI-augmented LSP, you hover over a confusing piece of code, and the server can generate an explanation of what that code is doing in real time. It is taking a UI element we are already used to and supercharging it.
But let's talk about the friction here. Traditional LSPs are fast, like sub 10 millisecond fast. They are running locally, usually written in highly optimized C++ or Rust. LLMs are not that. Even a local model has a significant time to first token. Doesn't that break the feeling of a fluid editor?
That is the biggest technical hurdle. LSP was designed with the assumption that the server is fast. However, the protocol does support asynchronous responses and partial results. The real challenge is managing user expectations. If you are used to the instantaneous feedback of a static analyzer, the 200 millisecond lag of an AI completion can feel like a stutter. This is why many of these tools, including lsp-ai, are focusing heavily on local inference and optimized caching.
It also changes how we think about diagnostics. In the LSP world, diagnostics are those red squiggly lines you get when you have a syntax error. Normally, a compiler finds those. But imagine an AI-based diagnostic server that doesn't just find syntax errors, but finds logical flaws or security vulnerabilities as you type.
We are already seeing that. There are implementations where the LSP server runs a background task that periodically sends chunks of the code to a model to check for smells. Instead of a red squiggle for a missing semicolon, you get a yellow squiggle that says, "This loop has a potential off by 1 error." And because it is using the standard diagnostic interface, the editor displays it perfectly without any extra configuration.
This brings me to the other project Daniel mentioned, copilot-lsp-nvim. Now, this one is a bit of a meta layer. GitHub Copilot usually requires a heavy, proprietary plugin. But this project essentially wraps the Copilot agent into a standard LSP server.
It is a fascinating bit of community engineering. It basically says, I want the power of Copilot, but I don't want to use the official VS Code-centric architecture. By exposing Copilot as an LSP, they've made it accessible to editors like Helix, Zed, or even older versions of Vim that might not have the latest node-based plugin support, but do have an LSP client.
It really highlights the shift toward LSP as the HTTP of the editor world. If you want to provide a service to developers, you don't build a plugin anymore. You build a language server. It is the most efficient way to reach the widest possible audience. It is a total reversal of the integrated development environment philosophy, where everything had to be under one roof. Now, it is a distributed system living on your local machine.
What I find most compelling is the second-order effect on innovation. When the interface is standardized, the barrier to entry for a new AI tool drops to near zero. If I develop a new way to analyze code using a specialized transformer model, I don't have to worry about how to render a menu in Emacs. I just implement text document/completion and I am done.
It also solves the dual track problem we've talked about before. For a while, we had our dumb editors and our smart AI sidebars. You'd write code in one place, then copy-paste it into a chat window to ask questions. By moving the AI into the LSP, you are merging those tracks. The AI is no longer a sidekick. It is part of the editor's core nervous system.
And it respects the context of the project much better. Because the LSP is already designed to understand project roots, file structures, and dependencies, an AI LSP server can automatically pull in relevant context from other files. It can see the create table statement in your SQL file and use that to provide better completions in your Python ORM code.
That was actually a specific use case mentioned in the lsp-ai documentation. It is such a common developer pain point. You are writing a query, and you can't remember if the column name was user_id or userid. A traditional LSP might not know if they are in different languages, but an AI server can just look at the open buffers and make the connection.
I want to go back to the statelessness of LSP for a second because it is a double-edged sword. Since the protocol is mostly stateless, every request should ideally contain what is needed to fulfill it. It makes the AI server's job easier, in one sense. But LLMs benefit immensely from state, like conversation history or a memory of what the user is trying to achieve. Keeping that in sync with the editor's view of the file can be tricky.
That is where the agentic part of the protocol comes in. There are extensions being proposed to the LSP spec to handle more complex AI interactions, but even within the current spec, you can do a lot with work done progress notifications. You can show the user that the AI is thinking or generating right in the status bar of the editor using standard LSP messages.
It is also worth noting how this impacts the conservative side of development. If you are at a company that is very careful about data privacy, using an LSP-based tool like lsp-ai allows you to switch between a local llama model and an OpenAI model with a single line in a config file. You aren't locked into whatever the plugin provider decided to use. You own the gateway.
It's the ultimate pro-consumer move in the dev tool space. It prevents the kind of platform lock-in we see with things like Cursor or even VS Code to an extent. If I decide I don't like VS Code anymore and want to go back to the terminal with NeoVim, I take my LSP configuration with me. My AI brain stays the same even if the eyes and hands change.
I've been looking at the actual JSON payloads for some of these lsp-ai requests, and the amount of data being passed back and forth is substantial. We are talking about whole file contents being serialized and sent over SDDO multiple times a minute. On a modern machine, it is fine, but it really shows why the protocol had to be built on such a solid foundation.
It's funny to think that a protocol designed to help Microsoft compete with Java's IDE dominance has become the backbone of the AI era. It is a testament to good interface design. They didn't try to over-engineer it. They just solved the problem of, how do I get code info from point A to point B?
And now point B is a GPU cluster in Nevada or a local NPU in your laptop. The destination changed, but the map stayed the same. This is actually a theme we touched on in a previous discussion about how repository architecture is evolving. When the protocol is stable, the underlying implementation can undergo a total metamorphosis without the user even noticing.
Let's talk about the downside, because it isn't all sunshine and automated refactoring. One of the things I worry about with AI LSPs is hallucinated diagnostics. If a compiler tells me there is an error on line 42, there is an error on line 42. If an AI LSP gives me a red squiggle because it thinks my logic is wrong, but it is actually fine, that creates a lot of cognitive load.
That is the trust but verify problem. Traditional LSPs are deterministic. AI LSPs are probabilistic. Mixing those two in the same UI can be jarring. You might start ignoring the red squiggles if they are wrong too often, and then you miss a real syntax error. The developers of lsp-ai have discussed this. How to score. The confidence of a model before showing a diagnostic to the user.
It's almost like we need a new color of squiggle. We have red for errors, yellow for warnings, maybe purple for the AI has a hunch.
I actually love that, a probabilistic squiggle. But honestly, the way most people are using it now is for the ghost text, completions. That seems to be the sweet spot. You see the suggestion in gray and you hit tab to accept. It is low stakes and high reward.
And that is exactly what copilot-lsp-nvim excels at. It brings that ghost text experience to editors that weren't originally built for it. It hijacks the completion ghosting mechanism that was originally intended for things like snippet expansions.
What is really impressive about the Copilot-LSP project is how it handles the agent part of Copilot. Copilot isn't just a simple completion API, it has a whole lifecycle. It manages authentication, telemetry, and complex multi-file prompting. The fact that the community was able to wrap all of that into a standard LSP server shows how flexible the protocol really is.
It also points to a future where we might see multi-LSP setups. You might have the official Rust analyzer running for your hard syntax and type checking, and then a secondary AI LSP running for your creative coding and refactoring suggestions. Most modern editors can connect to multiple servers for the same file.
That is the defense in-depth strategy for coding. You want the compiler to keep you honest, but you want the AI to keep you fast. By running them as parallel LSP servers, they don't interfere with each other. If the AI server crashes or lags, your basic type checking still works. It is a very resilient architecture.
I'm curious where you think this goes in the next year or two. Do we stick with LSP, or does it eventually buckle under the weight of AI-specific needs?
I think we will see LSP 2.0 or a dedicated AISP, an AI service protocol. There are things LLMs need that LSP doesn't provide well, like streaming long-form text generation or multimodal inputs. If I want to send a screenshot of a UI bug to my editor and have the AI fix the CSS, LSP doesn't really have a clean way to handle that image data right now.
True, but looking at how slowly standards move, I bet the community will just keep hacking LSP to make it work. We'll see people embedding base 64 images in JSON fields before we see a new protocol gain universal adoption. Developers are lazy in the best way possible. They'll use the tool that's already there.
That is a fair point. The gravity of the existing editor support is massive. If you want to reach every developer, you have to speak LSP. It's the lingua franca.
So, for the developers listening who are tired of being locked into a specific AI's IDE or a specific company's plugin, what is the move?
The move is to look at your editor-server relationship. If you are using VS Code, try disabling the internal Copilot plugin and setting up lsp-ai with a local model. Or, if you are a NeoVim or Helix user, look into the Copilot-LSP projects. It is about taking control of the interface. Once you realize that the smarts of your editor are just a stream of JSON messages, the world opens up.
It really is an unbundling of the developer experience. We unbundled the compiler from the editor with LSP, and now we are unbundling the AI from the editor. It's a great time to be a nerd who likes to tinker with their config files.
It also makes the open source AI movement much more viable. If you can run a local model that speaks LSP, you have a fully private, fully offline, professional-grade development environment. That was a pipe dream 2 years ago. Now, it's just a download away.
And it's not just for the ultra-hardcore. Projects like lsp-ai are getting easier to configure. It's not just for people who want to write their own Lua scripts. The goal is to make it a drop-in replacement.
I think the biggest takeaway for me is the shift in how we view the language server itself. It's moving from being a dictionary to being a co-author. A dictionary tells you if a word is spelled right. A co-author helps you finish the sentence. Using the same protocol for both is a stroke of accidental genius.
It reminds me of how we used to think about compilers as these black boxes that just spat out binaries. Now the compiler is a service. The AI is a service. Everything is an API.
And that brings us back to Daniel's prompt. Why is this important? Because it prevents the balkanization of development. We don't want a world where you have to use the Anthropic editor to get Claude or the Microsoft editor to get Copilot. By pushing all of this through LSP, we keep the web of development tools open and interconnected.
It's the pro-Israel. Pro-freedom of choice stance for developers. Don't let the big tech silos build walls around your workflow. Use the protocols that were designed to keep things open.
I think we've covered the technical why and how pretty thoroughly. The what's next is really up to the community. Projects like lsp-ai are still in the early stages, but the momentum is incredible.
It's the classic worse is better philosophy. LSP might not be the perfect protocol for AI, but it is the one that is everywhere. And in software, everywhere usually beats perfect.
I'm just waiting for the day I can talk to my LSP server. Not type, just talk. Hey, LSP, can you refactor that class while I go grab a coffee?
Knowing you, Herman, you'd find a way to make it run over some obscure protocol from the 1990s, just for the fun of it.
If it has a spec, I will implement it.
Alright, I think that's a good place to wrap this one. We've gone from the plumbing of JSON RPC to the future of AI-human collaboration, and I think I actually understand my editor a little better now.
It's all just messages in the dark, Corn.
Deep. Very deep. Well, thanks for the deep dive, Herman. This was a fun one to pick apart.
Always a pleasure. I love getting into the weeds on this stuff.
And thanks to Daniel for the prompt. It's wild how a simple protocol can have such a huge impact on our daily lives.
It's the quiet stuff that changes the world.
That should be our new tagline, My Weird Prompts, exploring the quiet stuff that changes the world.
We'll have to check with the producer on that one.
Speaking of which, big thanks to our producer, Hilbert Flumintop, for keeping the gears turning behind the scenes.
And a huge thank you to Modal for providing the GPU credits that powered this show and our experimental AI research.
If you're finding these deep dives helpful, or if you just like listening to a sloth and a donkey talk shop, leave us a review on Apple Podcasts or Spotify. It actually helps a lot.
It really does. We read all of them.
This has been My Weird Prompts. You can find us at myweirdprompts.com for the full archive and all the links to the projects we talked about today.
Take care of your config files, everyone.
See ya. See ya. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the close from sloth